Here we have the graph y equals 2 to the x, which we plotted in example 1. We have minus 3 1/8, minus 2 1/4, minus 1 1/2, 0 1, 1 2, 2 4, and 3 8. This is the curve y equals 3 to the x. We can see that to the left of the y-axis, the blue curve is below the red curve, but it goes through 0 1, just like 2 to the x, because of course 3 to the power 0 is 1. All exponential curves, as mentioned, will go through this point. 1 3, 2 9, and 3 27. So to the right of the y-axis, 3 to the x is above 2 to the x. So the curves cross at the point 0 1. As mentioned, to the left of the y-axis, the blue curve is below, and for example, 2 to the minus 2 is 1/4, but 3 to the minus 2 is 1/9, so we can see why 3 to the x is below 2 to the x to the left of the y-axis. If we now consider to the right, it's clear that 2 squared is 4 and 3 squared is 9, so 3 to the x will be above 2 to the x. Here we have two further curves drawn on here. This one is the gradient function of 2 to the x. We don't know how to differentiate 2 to the x, but if we did, this would be its gradient function. The green curve, which we can see above, is the gradient function for 3 to the x. We don't know yet how to differentiate 3 to the x, but if we did, this would be its curve. If we consider both gradient functions, we can see they have a similar shape to the original curve. But for 2 to the x, the gradient function is below 2 to the x, and for 3 to the x, it's above. The thinking might be that since the gradient function of 2 to the x is below y equals 2 to the x, and the gradient function of 3 to the x is above y equals 3 to the x, that somewhere in between there might be an exponential function such that the gradient function lies exactly on the original function. Here we can see this curve. It's called e to the x. The yellow curve here is y equals e to the x, and the blue curve is its gradient function. E is a special number equal to 2.718 and so on. It's an irrational number, just like pi, and goes on forever with no recurrence. This important feature of the gradient function lying exactly upon the original function is an important feature, both mathematically and in many areas of nature where mathematics applies. Because this is so important, this curve tends to be called the exponential function. Remember, an exponential function is something like 2 to the x or 3 to the x. E to the x is called the exponential function.